Okay, so we have quite a few more rules. So if a tangent and a secant or a chord intersect a circle at the point of tangency, then the measure of the angle formed is half the measure of the arc that it intersects. So for example, I have tangent AB and I have chord AC, and this could very well be a secant as well. Now angle A with the tangent and the chord form this arc, and angle A would be half the measure of angle B. That's what it's saying in this theorem, and I also have it written up here that the angle of a tangent and a secant or chord intersecting at the point of tangency is equal to half the intercepted arc measure. So that's another formula that you would need to know. The next one, it says if two secants or chords intersect in the interior of a circle, then the measure of each angle formed is half the sum of the measures of the arcs it intersects. So here I have two chords intersecting inside of my circle. And when this happens, angle X here would be equal to, I'm going to label arc BE as Y and arc BC as Z. So angle X is equal to half the sum of those two arcs. So that's actually what I have written here. The angles of two secants or chords intersecting inside of the circle equals half the sum of the intercepted arcs. And then our last one for this lesson is if we have two tangents or a tangent and a secant, or two secants intersecting on the exterior of a circle. So here I have two secants intersecting on the exterior of our circle. Then the angle formed, so angle X here, and I'm going to label this Y and Z. So this arc is Y and this smaller arc is Z. Then the angle X is going to be half the difference of these two arcs. So X is going to be equal to half the difference. We take the bigger arc minus the smaller arc. And that's what I have in this third equation up here. The angle that's formed by tangents or secants intersecting outside of the circle is equal to half the difference of the arcs. So these three equations, you need to add it to your list of things that you would need to know. Let's get started. So we want the measure of angle STU, which is an angle formed by the tangent TU and the chord ST. The arc that is formed by this angle is this arc here. We can kind of think of this as an inscribed angle because it kind of looks similar to an inscribed angle. And it also has the same rule as an inscribed angle. I would just take half the sum of the arc, or half the arc. So 166 divided by 2 gives me 83 degrees. And then we want the measure of arc SR, which is this arc here. And that arc is actually formed by this angle, which again kind of looks like an inscribed angle. It's a slightly different. It uses the same rule though. It's an angle formed by the tangent and the secant. So if I do 71 times 2, I would get my arc length, which is 142. Okay, looking at number 33. So we have to find all the unknowns. So we're going to find A, B, and C, given what we have here. So there's quite a few things going on. You may see these little arcs on worksheets. That it's not going to mean that those angles are congruent. It's just showing you what angles we're talking about here. So let's get started. I'm going to start with what I'm given. So I'm actually given this angle here. And again, it helps if you highlight the angles. It puts it into more perspective. This is an inscribed angle intersecting this arc. So remember, an inscribed angle is half the measure of an arc. So if I do 52 times 2, that gives me that this arc is 104 degrees. But what else intersects this arc is this angle formed by this chord and this tangent. And remember that the rule is that is half the measure of the arc that it intercepts. So half of 104 makes that this angle's 52 degrees. If that angle is 52 degrees, these three angles together should equal 180. So if I do 180 minus 52 minus 34, I get that this whole angle here is 94 degrees. Well, this is a triangle, and a triangle adds to 180. So if I do 180 minus 94 minus 52, I get that angle A is 34 degrees. Something else that is interesting is angle C is an inscribed angle also intersecting that yellow arc of 104. So 104 divided by 2 gives us that angle C is 52 degrees. And then now for angle B and angle A together subtend or intercept a semicircle. So that means angle B and angle A together are a right angle. So if I do 90 minus 34, I get that angle B is 56 degrees. So notice we have to use a lot of what we learned to help us figure out this problem. But this is our answer. Okay, moving on to the next page, we want to find angle ABD, which is created by two, like a secant and a chord intersecting inside of your circle. So this, I'm going to label this angle X, is equal to half the sum of the arcs that these two lines intersect. So 65 and the 37. So just typing that into my calculator, a 65 plus a 37 is a 102, and then divided by 2 or times 1/2 gives us that X is 51 degrees. All right, looking at the next one, we want the measure of angle R and M. In order to find this, we're first going to have to find the angle of R and P. So I'm going to label that X for right now. That angle is equal to half the sum of the arcs that it intersects, which is 225 and 91. So X would be equal to 225 plus 91 times a 1/2 or divided by 2 is a 158. Now, these two angles create a straight line. So to find the measure of angle R and M, I would just do 180 minus that 158 to get our angle measure, which is 22 degrees. I want to find the unknowns for this. So, this angle here is a central angle. A central angle is equal to the arc that it intercepts. These two are vertical angles, so this is also 121, and this angle is also a central angle, so it's equal to the arc that it intercepts. So doing 360 minus 121 minus 42 minus another 121, I get that angle Y, or arc Y, is 76 degrees. Now to find X, X would be equal to half the sum of the two arcs that it intersects, which is the 42 and the 76 degrees. So a 42 plus a 76 is a 118, times a 1/2 or divided by 2 is a 59 degrees. All right, my next one. Now I have two secants intersecting on the outside of my circle. So this angle here, 25, is equal to half the difference of the arcs that it intercepts. So we do the larger arc minus the smaller arc. Using the distributive property, I'm going to distribute the 1/2 in. Subtracting the 41.5 over, I get this. And to get X by itself, I'm just going to multiply by 2, or by -2 here. So 33 degrees. All right, the next one. I'm going to actually jump to number 39 real quick, just in case I run out of time. So for this one, a full circle equals 360 degrees. So if I do 360 minus 252, I get that this arc is 108. We need that because I'm going to find X, and X is equal to half the difference of the two arcs. So a 252 minus a 108. So X comes out to be a 72 degrees. Okay, so for the next one, this 34-degree angle is equal to half the difference of the two arcs. This one we need to be careful. We're going to take the 3x minus 2, but then I'm going to subtract the x plus 6. But I need to put that x plus 6 in parentheses because I'm going to need to distribute that minus sign in. Then I'm going to combine like terms. (3x minus an x is a 2x, and a -2 minus a 6 is a -8. Distributing the 1/2 in. And then adding the 4 over, I get x is 38 degrees. All right, that brings us to the end of this lesson.